My name is Alex Chen. I'm the offering executive for file storage, software-defined file storage. We have primarily 3 software-defined storage offerings for the unstructured data, and some people may ask, well, why do you have 3? The key difference of the 3 is architecture, and the architecture determines what is this particular offering is good for, what type of workload it's good for, what kind of application it's good for. So we have, on one hand, we have Spectrum Scale, which have heritage of HPC. It's the world's fastest file system or file storage out there, and it's parallel file system based on very enterprise erasure coding type of rate protection of data protection, and it's really good for high performance computing. It's good for big data analytics, machine learning, deep learning, because it's vastly scalable. It scales to in terms of number of objects, 50 billion objects tested, and it scales performance wise to 2.5 terabytes per second tested. So it's really good for performance and even small I/O performance, small file performance as well. It's got the new feature coming in the Spectrum 5.0 in terms of sub-block optimization, so you can read and write and store efficiently small files. We're positioned that product because it's heritage and architecture in high performance, high requirement workloads. Like again, machine learning, deep learning, AI, HPC type of workload. And then we have, as you all know, have cloud object storage, which is the #1 object storage solution out there in the industry. And that solution is very efficient in terms of storing data across multiple sites without having to replicate the data using a global geo-dispersed erasure coding. And it's got excellent object storage native API, and as well as a lot of the object storage native services. And that particular object storage offering is object storage is really efficient for storing large amount of static data, right? The data that basically are created once but read many times, but not necessarily updated very frequently, but so we call it static data. And sharing that massive amount of content and static data across the geos and the enterprises. And then recently we just introduced a new product called Spectrum NAS. And Spectrum NAS is really your everyday, type of workhorse that does general purpose file services. And the key here is about it's not only it's a software-defined storage in the sense that it runs on commodity server, but it also allows your applications, or you can define your application users can define the behavior of the storage. So for example, you have a very perhaps enterprise application and you need your data to be protected, maybe N+3, so or you need your data to be replicated across 2 sites. So your application can decide what your data's storage policy is. And it's basically a pool of storage, but then it can be tuned to whatever your application wants to run. And it's very easy to deploy. It deploys under 30 minutes or less, and it's very easy to manage. So that's kind of the 3 architectures we really have. We have real super fast file storage. We have one that's for static data, but massive amount of static data, and optimized for content sharing. And then we have your average use type of NAS environment. First of all 3 of these offerings have fundamentally a scale-out architecture. There's some commonality among software-defined, and you're right that sometimes vendor kind of pushes its own agenda. When you take a software that exists in a particular storage system and you run on a virtual machine and you call that software-defined. Well, for us, the software-defined is much more than that. One is it's got a scale-out architecture, so that it's not limited by just a number of you can add more nodes, which has more capacity as well as performance. Second, it's got to be able to run on a set of industry standard commodity servers, right? No specialized hardware. That's for everybody. And often our software-defined storage are both deployable inside of a virtual machine as well as bare metal. So a virtual machine is not necessarily an absolute requirement. And the other part is about software defining what the storage policy is, which is software defining the storage. And that's the part that we're introducing Spectrum NAS and be able to have the flexibility to have one storage environment but run different various type of applications. So excellent question about, do we need to, that all the software runs on all hardware, or does it come with an appliance, if you will? So if you actually, I want to refer to some of the analyst surveys, there is a group of segment of the market or the customer that just wants to consume appliances. And even if they buy a software-defined solution, which they like the idea of software-defined value, meaning that you're not buying a hardware that's specially purpose-built, so you eventually long-term have the flexibility. But even with that, they still wanted to have one throat to choke, and they still wanted to have, a model where it's easily deployable. So there's a segment of the market, especially when you first start out in software-defined storage arena, a lot of people wanted to just buy an appliance that with most of the intelligence is building the software, we will call it a software-defined storage appliance. There's probably a third of the people that, a customer that really wants to just consume it that way, at least for the time being. And then there's those who want to just run the software on their choice of hardware. There's the model of we will publish a set of certified hardware, or there's the model where we publish a set of hardware minimum configuration that you need to meet. As long as you're above the minimum configuration, you can run on whatever vendor of hardware choice, HP or Dell or Supermicro or Lenovo, etc., or Cisco, right, etc. So, and then there's those who are really wanted to run software-defined storage in the cloud, whether it's a public cloud or a publicly hosted private cloud, whatever the cloud fashion it is, and running the software in that environment. So all three of them, we see customers wants to consume it that way. We don't restrict our license or deployment models that you can only run it in the appliance. We do offer appliance in many cases, like cloud object storage, and in the case of Spectrum Scale, we offer clients called Elastic Storage Server, but we also have we don't have one right now for the Spectrum NAS version, but in general, our philosophy is we would offer clients the flexibility to consume it as an integrated thing, or as software only, or as services on the cloud. The Spectrum Scale, or the artist formerly known as GPFS, it does have a certain amount of data governance built in, right? I mean, that's been there in terms of policy-based data movement, in terms of, be able to have some certain number of data on flash versus on disk, versus integrated with Spectrum Archive, or basically be able to move data to tape via some type of a self-prescribed prescriptive file system, and moving the data to a linear tape file system. So we do have that sort of policy in terms of to be able to manage data, sort of tier it where it matches the access or the use of data. But I think data governance goes way beyond just the placement of the data. And a lot of times when somebody is looking at data, I mean, even myself has probably thousands of presentations on my laptop but I wanted to perhaps look for one particular slide with one particular diagram, and I'm just trying to vaguely remember what day did I edit it, or how do I find that data, and it's very time consuming, right? And also imagine this for enterprise, finding data that are not necessarily indexed by the file system, or finding data or objects that are, basically that you don't know what you need until you need it, and it's in a sort of almost unstructured way that you're asking the question, I need that particular file from that time when I talked to this person. So how do you find these type of data in this is a massive environment? And sometimes it's about data that you don't own as well. A lot of what the enterprise today is not just about the data that you generate, but also the data that brought on, maybe through the cloud, through social media. The data or rated data that is not directly generated by your business. So how do you index? How do you massively find all these information that you're looking for and derive value out of it in a timely fashion? And that's the technology I think we're working on as well, called MetaOcean, is to be able to self-generating metadata, and so you can ask Watson to find certain things, and it will the data itself already has metadata and intelligence built in, so you can sort of instead of finding a needle in a haystack, you build a needle stack and find the needle. And there's a lot of uses for that, right? I'm sure my colleagues talked about this. If an employee left, you want to see what sort of files he touched in the last 30 days. There's a way to protect yourself against perhaps vulnerabilities and security and these type of things. There's a lot of application in this. And what we're doing on all software-defined storage, all of our platforms, is we're building the plugins to be able to have this MetaOcean to be able to event management or audit logging, that type of thing, so that when a file does get edited, gets changed, it will transfer to a bigger engine out there or generate additional data or the data about how the data have changed.